Madam, very good evening, Madam Veena ma'am. Hello, Madam. Good evening, Madam.
Hello.
Yeah, sir. Sirish garu.
Yeah. Hello. Hello.
Hello, sir.
Yeah. I'm audible. Arif. Professor Beena, how are you?
I think she's not audible. She has muted.
Yeah, she has muted. Yeah. Professor Beena, you need to unmute your system.
What are the rules like, sir? You will be running the show, or somebody else will be? How is it going to go?
Time management is your purview. Like a chair and co-chair have to manage the time. And
Okay,
what I do as a coordinator, I'll look after the. I mean, let us see how many presentations are there. And actually 6 minutes are given, so we'll take the numbers first, how many people are presenting, and after that we can either increase the time or keep the time as 6 minutes. Okay. First, I mean, I'll introduce both of you and then hand over the session to you. Okay. Yeah. Okay. So you're addressing sir. I'm just kidding. This is called Zirish, yeah. Okay. Welcome, friends. Are we audible? I mean, delegates. I think I can see like 4 or 5 here.
Sir, the session starts
at
we are 30 minutes early. We are actually the session starts at 4:20.
No. 4 o'clock.
No.
4 to 4:20 is the keynote. I mean, a theme note.
No, sir. You check the updated conference links, and there in the updated schedule, what they're given, it is 4:20 to 5:40, sir.
That is true. 4:20 to 5:40 is for the papers. Papers, and theme note is for 4 to 4:20. So we are on time. Murli, can you please share your screen and then see if you want to check, just in case. Murli?
Yeah, I'll do.
Able to hear me? Okay, good. Yeah, you can just start sharing your first slide or something, and maybe you can also opt your pointer. That will be easy.
Sure.
You present. So then you can, yeah. Professor Beena?
Still, she has not unmuted her mics.
Yeah.
Good luck.
You have her number?
No, I don't have her number, sir.
I don't have. Actually, there is a background IGC background they sent it recently, right? I'm trying to put it up, but it is not coming.
Dr. Sirish?
Hi, Beena. How are you?
Fine.
Good afternoon. Yeah, good afternoon. You are muted for some time, so.
Actually, I was hearing the other section.
Okay. Sure.
Good afternoon, everybody.
How are you? Ravi sir, how are you?
Oh, I'm very fine.
Nice.
Pleasure to
be
part of this.
Yeah, thank you. Thanks for joining here. No, you can see, right? No, what I can see is your
Actually, I can't see the
screen.
slides. I
Yeah,
can't see the
it's
slides.
not the slide. Actually, we are looking at the Google Meet link of from
Okay.
your, yeah. So you need to go. I think it's better to share the entire screen.
Yeah. Okay.
No,
Okay. I got it.
Yeah, go to the entire screen and then go for the presentation.
So all the registered papers, they reported here.
I think, ma'am, they're still joining. Um, dear friends, actually, may shall we know like how many of you are like going to present today?
I will be presenting.
Is it
Yeah.
okay now? Dr. Sirish?
Yeah.
Yeah,
Now,
yeah. Now it is
yeah,
fine.
it is visible. It is visible.
Fine, thank you. And you can go to right click, then choose the pointer as well right away.
May I know my co-chair?
User point. Arif Ali Beg, ma'am.
Arif Ali. Arif Ali.
Yeah, Arif is here.
Yeah. Madam, we
Yeah,
met at
yeah.
SPNIT Surat.
Ah,
Remember?
yeah. I remember that. Yes. You can switch on the video.
Yeah.
Let's just say hello.
Yes, ma'am.
Yeah.
I think
Yes, how are you?
How are you?
Good to see you all.
yes.
Actually, we could have this event, no? We could have met in physical presence. Makes
Yeah.
it enough. Yeah.
True, ma'am.
Actually, we're missing that part, but yeah, it was a good start in the morning also.
Yeah. It's
So we'll have a nice time. Uh, so may I ask the delegates to just identify their names and team number, like PS02, their probably their paper number, so that I can sit down here.
Mine is TH02 23.
23, yes, sir. And I request everyone to mute if they're not speaking. During the presentations, let us keep the mics off. Thank you very much. And last few minutes we'll give open for question answers, and probably you can switch on that. Probably video also, if you wish. Okay. Thank you for understanding. And we'll try to keep it on time. So it's just 4 o'clock. So how do we go about, ma'am? So what I'll do, I'll first introduce the chair and co-chair.
Yeah, first we have to see how many papers are there, how many papers are there to
Right.
present.
Right.
Yeah.
So I can see
Then only we can decide how much time we can.
correct. Friends, can you please use chat box to type your paper number? May I request you to type? 28. Excellent. Just type the last 2 digits. That would be fine.
$12 is there. Arya Das.
12. Yeah.
Or shall we call out the name?
I think it's easy, ma'am. They will be typing their paper number.
23.
Yeah, Ravi sir, I have already correct. Yeah, taken your number. Great.
26 is there?
26, no. So anybody from paper number 5, like Raviteja, Sai Baba Reddy, and Padmavati M, first paper. And paper number 6 from Deepthi, Nageshwar Rao, and Professor Madhav. Anybody is presenting?
Yes, sir.
Okay. And Mr. Dr. Rajiv Sarkar, Abhijit Anand,
Yes, yes,
anyone is here? Abhijit
yes,
Anand?
yes, Abhijit. Yes, sir.
Sure, sure. Please use a chat box here to type your number so that I don't need to call out names, please.
Adiodas, she has typed it.
Yeah, I have already picked it. So, Tanya Dev, Sujit Kumar Pal, um, Mr. Sridhu, Mr. Jayamohan and Kannan. Anybody is from paper number 15? And again, Professor Jayamohan, Anila Angel, Vipasha Das, Naimoni.
Yes, sir, present.
Okay, Vipasha Das is presenting. Okay, the number 26. Okay, ma'am, actually we have right now
Six,
6 papers.
6, 7,
Yeah.
12.
No, number 6, number 7, number 12, number 23, 26, and 28.
Okay, fine.
Sir, I'm from 214. I'm present.
Pardon?
Pardon me?
214. Sonoya Dev.
Yeah, 14 is there.
14, 14,
14
okay.
is there.
214.
Yeah. Tanya.
Is it Tanya Dev?
Yes,
Oh,
yes.
great. Okay. So there are 7 papers, ma'am. You can decide the time. Okay, so I welcome the audience here. I mean, delegates for the first technical parallel session on shallow foundations, theme number 2. I would like to introduce chair and co-chair today. We have Professor Beena from CUSAT, Cochin University of Science and Technology. She has joined this institute in 1999. Prior to that, she graduated from College of Trivandrum in 1984. Then she got master's from the same college. After that, she got PhD from IIT Madras in 1994. After that, she joined several organizations to get a hands-on experience and knowledge, like Irrigation Department of Kerala and so on. And since 2006, she has been professor in the College of, Cochin University of Science and Technology. She has been very active researcher and performed a lot of research on coir geotextiles and soft soils. Okay, and I'm just keeping it very brief. And she has been a very key person for 2011 Cochin, IBC 2011, which was conducted in Cochin. And she has been very active reviewer for various international journals, including the AAC Journal of journals like Materials of Civil Engineering, International Journal of Geosynthetics and Ground Engineering, and so on. She has been awarded with great scholarships and awards, notably the India Research Fellowship of Australian Government of Australia in 2015, and she visited as an ambassador, selected ambassador in 2017 as well. So with that, I welcome Professor Beena to chair the session. And we have Professor Ali Baig, who is actually Associate Professor at NIT Warangal, who is co-chairing and who is with us. He has been at Riyadh, Saudi University Riyadh in 2000, joined in 2010 there until 2018. Before he come back and as a chair faculty there, research faculty. And he obtained BTech and MTech from Sri Venkateswara University. After that, he obtained PhD from Indian Institute of Science, Bangalore. So now he's very active in soft soil engineering, especially expansive soils and mitigation of expansive soil problems. And he's very active researcher and published more than 75 papers. So now the floor is yours, ma'am. Dr. Ali.
Yeah, thank you.
Thank you.
Thank you, Dr. Sirish, for your elaborate introduction. On the outset, let me thank the organizers to give me this opportunity to take part in this very important technical session of IGC 2020. And I'm also very happy to share the platform with Dr. Mohel. So, regarding the session, it is on the theme is put as shallow foundations. We know the unstable, problematic soils pose significant challenges to geotechnical engineering. Such soils greatly hinder the infrastructure development, especially for structures with shallow foundations such as building foundations, roads, retaining walls, etc. The design and construction of any shallow foundation, it is based on its bearing capacity and settlement or compressibility. In addition to this, uh, there are a lot of research coming on this, on soil plasticity, then creep, soil structure interactions, foundation shape, then anchoring. All this, the several aspects are are the uh, topic of research, those who work on the shallow foundations, which affect mainly on the stability of the foundations. Apart from understanding the basic behavior of foundation soil, research is also going on in worldwide, how to tackle the difficult unstable soil and different ground improvement methods with which we can make use of the poor soil to our requirement. Application of geosynthetics, use of industrial waste materials, natural and locally available materials are a few innovations in this direction. I hope this session will discuss some of these aspects. With these few words, let me move on to my assigned duty to introduce the theme keynote speaker of this session, my friend Dr. Murali Krishna. Dr. Professor A. Murali Krishna joined Department of Civil and Environmental Engineering, Indian Institute of Technology, Tirupati in 2019. He is also serving as Dean, Planning and Infrastructure of IIT Tirupati. Before joining IIT Tirupati, he was a faculty member in Department of Civil Engineering in IIT Guwahati since 2008 for about 11 years. Dr. Murali Krishna obtained doctoral degree from Indian Institute of Science, Bangalore, MTech degree from IIT Kanpur, and BTech degree from Sri Venkateswara University College of Engineering, Tirupati. His research interests include earthquake geotechnics, geosynthetics, and ground improvement, site characterization, and numerical and physical modeling of geotechnical structures. He was a recipient of DRNS Young Scientist Research Award, Boycast Fellowship, and Heritage Fellowship. He was a visiting fellow at Bristol University, UK, Surrey University, UK, and University di Torino, Italy. He supervised 7 doctoral students and 24 master students, co-authored nearly 180 publications of technical papers in international and national journals, conference or seminar proceedings, including chapters. Dr. Murali Krishna is an executive member of Indian Society of Earthquake Technology, International Society of Rock Mechanics, Life Fellow of Indian Geotechnical Society. He is also a member of PC 203 of ISSMGE since 2011. He served Indian Geotechnical Society as an executive member for 4 terms, 2011 to 2018 continuously. Dr. Murali Krishna organized several national and international workshops and short courses, in particular Indian Geotechnical Conference 2017 at IIT Guwahati, which everyone appreciated his organizing skill. He is a consultant for several projects as well as a reviewer for several national and international journals. He was chairman, a vice chairman of GATE and JAM at IIT Guwahati during 2016 and 2019. With these few words, I invite Dr. Murali Krishna to deliver his theme lecture on performance of geosynthetic reinforced shallow foundations. And,
Yeah, thank you, Professor Bina. Is my voice clear? Am I audible clearly?
yes.
Yeah.
Thank you, Professor Arif, for this session sharing. Let me share my screen. I hope you can see my slide.
Yes, sir. Yes, sir.
Okay. So thank you all. Good evening, everyone. So thanks for the IGC 2020 organizing committee for inviting me to deliver this theme lecture. I'm missing this IGC gathering personally. So because after so many years, this is the first time we are not meeting our peers. Otherwise, a lot of gathering. This is what we are missing. But one thing to note: everybody is staying safe and able to join the attend the sessions. That's a good thing to note. So coming to my topic, shallow foundations theme lecture. I have chosen the topic of performance of geosynthetic reinforced shallow foundations. This is basically co-authored by Dr. Argadeep, who was my PhD scholar at IIT Guwahati, who is currently working as an assistant professor at Jalpaiguri Engineering College, Jalpaiguri. I hope Argadeep is also here. Argadeep, are you here? You can
Yes,
say
sir.
hi. Yeah, hi. Good to see you.
Yes, sir.
Good to hear you.
Thank you.
Yeah. So his main work contribution. So this is how I organized my topic content this way. I'll briefly introduce the need of ground modification and talk about various options of reinforced foundations, and we'll be discussing briefly about the experimental studies and some performance observations from the numerical physical model studies in terms of homogeneous soils, layered soils, and reinforced configurations. And I'll try to highlight the comparative performance and the various mechanisms, and then briefly concluding remarks. As the time is very limited, I just made the presentation very simple, and other relevant information can be obtained from the paper, whatever thing. The basic objective of a foundation design is to design a safe and economic foundation and substructure, include foundation and the substructure together. So the various aspects involve evaluation of the capacity of the soil to support the loads, and once the foundation sizes are designed, then properly designing the structural element to transmit the load to the soil. This is what the basic objective. So when we consider both the structural element and the surrounding soil, the foundation system is not only the structural element and not only the soil, it's a combined together. So some soil underneath the foundation also part of the foundation system. So that is the very fundamental of this fundamental aspect of the shallow foundation. So when we talk about various foundations, we have the class of shallow foundations and deep foundations, or combined foundations, where you have the pile raft foundation, where the both shallow foundation feature and deep foundation features would be combined. So these are various types of foundations. So shallow foundations are generally preferred because they are very simple and inexpensive compared to the other types of foundation, for example, deep foundation or combined foundation. So, however, there would be certain instances where the deep foundations would need to adopt it based on the site conditions and structural loads and local availability, right? So, what are the problems and challenges associated with the shallow foundations? If the soil is not strong and stiff soil, then we'll be having a unsatisfactory bearing capacity of the soil, and associated excessive settlement related problems would be there generally. Generally, the designers will tend to adopt a deep foundations in such instances. However, one can go for the ground engineering and ground improvement option. That is where the linking of the shallow foundation ground improvement things will be there. And various methods are available in the ground improvement for ground engineering. Among them, the soil reinforcement is widely being accepted and being in practice in the last 3-4 decades. We can see several instances, many places. Soil reinforcement geosynthetics are being applied. When you talk about the geosynthetics, there are different types of geosynthetics are there in the strip type reinforcement, sheet type reinforcement, and cellular type cells type 3D reinforcements are there. Some of the pictures of geosynthetics I'm showing here. This is sort of strip reinforcement you can see here, and other things are like planar type reinforcement. This is the geotextile, woven geotextile is here, and geogrids are here. This is the combined geosynthetic material, a planar type geosynthetic material, which is having some drainage medium and also some filter medium together. And other 3D form of reinforcement, or these are the geocells, so which is the cellular form of reinforcement. So it can be of different shapes. You can see the vertical walls are this particular wall is completely closed. So whereas these walls have some perforations of different sizes and all. These geocells can be obtained onto the site like this one, very collapsed form. So which can be extended like this one, and we can open up this one, we can extend, and to fill this material to proceed with the construction. So geocells can also be prepared using the geogrid material like this one. So these are the unfilled, they were prepared. This geocell is a factory made geocell which was directly bought and placed. These two and the top two one, they are prepared on the site. The advantage of on-site preparation geocells means they can be prepared to the any different sizes, particularly when we need to use for the very larger areas. However, in the context of shallow foundations, if you see, so mostly the readily available geocells would suffice the need of the requirement. So now, when we adopt the reinforcing the foundation, what are various options if you want to modify the foundations? Let us see here. So let us take a ground. Hypothetically, I am taking a case of homogeneous clay or homogeneous ground. However, in practice, reality, the ground is not homogeneous. There are certain things would be there. And another hypothetical case is taken here is the surface foundation. Otherwise, generally, we will be embedding the foundation to some depth. That is what the practical thing. However, here, the homogeneous soil case and the foundation resting on the surface has been taken. Yes, this foundation soil has some problem, whole system, and we need to improve the capacity. And one option would be first taking the top a few meters or few centimeters of the soil can be taken and replaced with other good quality of soil, generally the sand or other type good cohesionless material, or sometimes M sand or quarry dust. These are the things also can be used to fill the top some part of the soil. So which can be a layered configuration and unreinforced, basically no other reinforcement has been placed here. So this is one type of configuration one can adopt to improve the capacity of the soil. Otherwise, we can also include some layer of reinforcement in between the interface, a single layer, or we can also use the multiple layers of reinforcement, starting from the top of the bottom of the footing, and we can come to the interface also. That is what more practically can be considered. But however, in this case, we are taking one planar reinforcement at the interface between the two materials is one option one can consider. And the next option is to use the three-dimensional geosynthetic material in the form of geocell, placing directly at the interface. Okay, this is the one more option one can consider for the getting the advantage of the foundation. Here, there is certain parameters were involved. So the U is the top depth of the geocell from the surface, and H is the thickness. Small h is the thickness of the geocell, and capital H is the total thickness of the sand layer. Geocell total geocell reinforced sand thickness we can see, and small p, which is represented as the total width of the foundation, which can be in proportion to the footing. And another option is keeping the geogrid at the interface and placing the geocell over this geogrid is another option one can consider. So these are various options one can adopt for improving the capacity of the shallow foundations using different forms of the geosynthetic reinforcement. To observe the performance of these different model studies, experimental studies conducted by Biswas, Argadi Biswas, which was defended his thesis in 2016. A very thorough study has been done, considering the different types of the subgrade soils, having different undrained shear strength values of 7, 15, 30, 60 kPa, and also a uniform sand of relative density of 80% has been taken, and a different configuration of the reinforcing foundation configurations are taken as discussed just previously. So various parameters have been varied as shown in this particular table. So for example, thickness of the sand stratum or geocell reinforced sand stratum is represented in terms of the capital H by D as a non-dimensional values here, and D is the capital D is the diameter of the footing, which has been taken as a 150 mm diameter. The circular footing has been taken for the preparation of the footing. So like this, various series of tests have been conducted, and I will try to highlight the performance of these different configurations and then comparative performance. So a little bit more into the details of the experimental setup. This is the testing tank of 1 meter by 1 meter size in plan and 1 meter height. And you can see here 150 mm diameter of the circular footing, and various dial gauges were placed on the surface to monitor the deformation on the surface. And the load has been applied using the hydraulic job. As we saw in the earlier thing, the various materials used in the particular study were clay, having these properties, of course, prepared at different undrained shear strength CU values, and sand material having these properties and prepared at 80% relative density. And of course, geogrid as a geosynthetic material, geogrid has been taken. This geogrid has been used as a planar reinforcement horizontally, and also the same geogrid has been used to prepare the geocells and forming a three-dimensional geosynthetic material. So this is another picture showing the preparation of the sand clay bed, and you can see the picture here keeping the planar geogrid placed on the top of the clay subgrade, and here you can see the geocell prepared using the geogrid, and this picture shows the geogrid has been placed at the bottom, and over that one a geocell was placed. This is how the different configurations. Now let us see the a simple bearing pressure deformation responses in various foundation configurations. Starting with the homogeneous foundation configuration, this is the configuration has to be taken. So as shown in the table, 4 types of the clay subgrades were taken, ranging from 7 to 60 kPa. Obviously, with increase in the shear strength of the soil, we would be getting the higher resistance in the bearing capacity. Same thing can be reflected here. So for this line, this is a sand capacity has been shown here using this particular diagram. Referring to this one can say the sand at 80% relative density is stiffer compared to the clay subgrades up to 630 kPa, And however, this sand is softer, means weaker than the clay subgrade of 60 kilopascals. So once these capacity, whatever has been obtained, the bearing capacities, they are compared with the classic theories available for the determination of the bearing capacity. Simply, for clay subgrades, the bearing capacity values were compared using the classic equation with NC factor taken as 5.14 Cu. Directly, these values are compared here. Reasonably, the experimental values findings were reasonably comparable with the theoretical findings. So next one is the layered foundation system, as shown in this figure. Here, the thickness of the sand layer H has been varied from 0.63 to 2.17, and the responses were obtained. You can see here the for a homogeneous sand, the responses are shown here using this particular graph. And when the layered configuration having the H as a 0.63 times the diameter, a small thickness of the sand layer has been placed. You can see the improvement in the bearing capacity for different clay subgrade values. So among these things, we can clearly identify the particular increase in the capacity in terms of the very soft subgrade here, 7 kPa, the difference we can see, and then 15 kPa subgrade, the difference also we can see significantly. Among this one, the 15 kilopascal subgrade having the layered simple unreinforced sand has been significantly contributed for increase in the bearing capacity. So these are some other height of the sand layers. If you see here, H values are varied from 0.63 to 2.19. And for very soft clay subgrade, how different thickness of the sands contributed in increasing the bearing capacity. And similarly, this figure shows for 15 kilopascal bearing under Cu value, the increase in the capacity for different thickness of the sand layers. From this, you can see for the very soft soil, the thickness is very significant in improving the capacity of the whole foundation. However, for the 15 kilopascal thing, even nominal small thick layer of 0.63 times the diameter thickness layer also has significantly increased, and further not much change in the capacity up to some 12% of settlement we can see here. This is one observation we can see. So what we can see in a moderately soft soil and not very soft, moderately soft to medium stiff soils, even keeping a small layer of sand will significantly improve the bearing capacity. So the capacity analytical evaluation of this bearing capacity can be compared with the observations. This is the typical observations what was observed. So when we have the layered configuration, a cone of formation clearly visible, showing the clear penetration here. So these analytical formulations were used in two cases. One is the dense sand over the soft clay. This formulation was used for calculating the capacity up to 30 kilopascals of undense shear strength soil. So whereas this one, the other category condition will come. So where the top one is the loose sand compared to the stiff clay at the bottom. Loose sand means it is not loose sand. So it is relatively softer compared to the soil capacity. Using these equations, the capacity foundation bearing capacities have been evaluated. So these are also reasonably, they are comparable with the theoretical calculations. So next category of reinforcement category is the geogrid reinforced category, which is one layer of geogrid placed at the interface, and keeping the same the height of the sand layers of 0.63 to 2.190, various tests have been done. So this is the unreinforced condition. That means sand has been placed here, but without reinforcement, how the bearing capacity, and with reinforcement, how the capacity has been increased at 0.63 times the diameter, depth. This is the significant improvement we can see here. So the difference between these two lines clearly provide what is the contribution of the geogrid reinforcement in enhancing the reinforced foundation capacity. So this figure shows the for various CU values. So for example, CU 7 kPa, even CU 60 kPa, and having the sand bed and also having the geogrid reinforcement at the interface. So we can see the significant improvement in the bearing capacity. Just to wanted to take your attention here. So even you see here, even the very stiff subgrade of 60 kilopascals of strength could get the improvement while when we use the geogrid at the interface. We can see that improvement also can be obtained. The reinforcement mechanism in this case can be explained with reference to the membrane effect, which has been reported earlier by Love et al. And various other researchers who has conducted the studies. And you can see here the depression penetration into the subgrade is minimized with the use of the this geogrid. So using the theory proposed by Love et al., the capacity of the reinforced foundation is evaluated, which are also compared in this particular figure, which are again reasonably well. So next class is the geocell reinforced foundations. So the three-dimensional elements. So placed directly on the clay subgrade, and again the responses for different clay subgrades we can see here. So in difference of the dashed lines, this is for the geocell only geogrid configuration. And if the reinforcement in the form of three-dimensional geocells are used, then we can see again further increase in the bearing capacity for the 0.63 times the 63D as the thickness of the geocell. So this, if we increase the thickness of the geocell and the thickness of the sand layer, the improvements can be further enhanced as shown in these figures. For example, if you take the very soft clay subgrade CU 7 kp, you see the capacity has been increased to many fold. Okay, so many fold it has been increased. So even in the case of the very stiff subgrade, also using the geocell, so very significant, almost 3-4 folds of the improvement can be easily seen in this particular figure. So the improvement reason for the improvement and mechanism are shown in this particular figure. So various mechanisms would act. The interaction between the soil and vertical walls of the geocell is one aspect, and the confinement of the geocells, which will provide the more resistance to the soil, and also the membrane effect also has been shown as a beam-like mechanism. As a whole geocell can be acting as a beam-like mechanism, that's also will be acting. So quantifying these effects into the analytical things and for calculation the bearing capacity. So the studies Zhang et al. Significantly provided all the contributions and gave the formulations to calculate the bearing capacity as shown in this particular figure, which can be used to calculate the capacity of the geocell reinforced foundation system. Again, these capacity evaluations were compared with our experimental studies. This is for the CU 30 kilopascals for S by D as the 12% settlement level, and this is for various subgrade strength of soils having the H as the 1.15D and 12% settlement. The things were compared. Among these, the CU 30 kilopascal, 60 kilopascal, they very well matched with the theoretical calculations. Bearing capacity. So further, this figure shows the change in the thickness of the geocells and associated effects can be clearly seen. when you are having the geocell and geogrid, there is a significant increase in the bearing capacity which can be taken here. So having seen all the different forms of reinforcement and their contribution, this slide is trying to highlight what is the comparative performance. For example, CU of 7 kP, a very soft subgrade has been taken. For the H value of the 1.15D has been taken, and the different types of reinforcing configurations can be seen. This is a homogeneous clay at the bottom, and this is only clay and sand. Even you got the significant improvement. So only providing the geocell or geogrid reinforcement on the directly on the sand could not make much difference up to 12% of settlement. But however, providing the geogrid and the geocell from the starting of the settlement itself, it significantly improved the performance. So this is what one important observations one can see as a superiority level of reinforcement. Geocell, geogrid is there, means you got significant improvement at all the settlement levels. On the other hand, if you see the other class of subgrade of 30 kilopascals subgrade, you can see there is a significant increase beyond the 6% of settlement. So you could get the significant advantage of various forms of the reinforcement clearly, very well defined. This is how the performance can be improved as per the requirement, depending on the subgrade strength of the soil. So just to recall the various mechanisms altogether. So in the layered configuration, you will have this type of behavior, and the depression and penetration would be of this level can be expected. These are particularly for the soft subgrade are presented. If you are providing the geosynthetic reinforcement, you have the membrane effect, and penetration into the bottom soil can be minimized and more performance can be obtained. And next, using the geocell reinforcement, you can see the use all the mechanisms like membrane effect and beam-like mechanism and confinement effects would be there, so which are very effectively used. And then when you provide the bottom reinforcement, so what it will do, it will interlock with the system, this geogrid system, and there will be locking between the geocell and the geogrid also will be there, and much more improved performance can be obtained when you have this particular system. Yeah, this is the interlocking mechanism what can be seen here. So this is how, depending on the contributions, one can see the different levels of improvement in the shallow reinforced systems. So with that, I am coming to the concluding remarks. This is a study, just briefly it showed geosynthetic reinforcement in any form is very effective in enhancing the foundation capacity. So we can note that geocell geogrid combination has provided the higher performance, and geogrid being the lowest among the reinforced configuration. In fact, unreinforced layered configuration also could improve the bearing capacity of the system. And overall, the whole improvement or performance depends on the level of the pudding settlement and what is the layer thickness, how much is the layer we are keeping over that in situ soil, and what is the strength of the subgrades in situ soil. That is very important to take into consideration, which is significantly inferior. So when we deal with these different types of configurations, as discussed in the previous slide, different mechanisms would operate and contribute to the improvement in the performance. The subgrade strength, irrespective of the presence of the reinforcement, largely influences of the foundation behavior, whether we are putting reinforcement or not. That is one thing needs to be considered. So it is to be noticed that improvement levels were decreased with the increase in the subgrade strength. However, total improvement in relative values, if you see, so even the stiffer subgrades having the reinforcement could contribute much improved bearing capacity. So just to considering this all the improved performance, one should note that reinforced shallow foundations may provide alternative solution to deep foundation under certain circumstances. It is not necessary to go for the deep foundations if some of the performance requirements are not satisfying. Using the geosynthetic reinforcing foundation under shallow condition itself, we can meet the requirements. So with this, I thank you all for your patient learning. Thank you.
Thank you for that wonderful presentation, sir. Madam, would you like to take up?
Yeah, thank you, Dr. Madhu Krishna, for excellent presentation. Shall we give the summary later? Finally, we'll give the summary and.
No, madam. We are running short on time, actually.
Okay.
Yeah, we'll go ahead and we'll take up.
Okay, then. Anyway, it was a very clear and very useful presentation in which he elaborated the effective reinforcement, especially the geocell and geogrid, and how it can be used. The mechanism also he explained very well, and how we can use it to improve the soil. And he has suggested that in some cases we can replace deep foundations with geosynthetics also. I request from the audience any quick questions or also quick questions we have to cater. So any we can take one or two quick questions.
Yeah. Hello. Myself Ravi Chekka.
Yeah.
It's a very interesting presentation, and it's very tedious to do any testing on the soil, particularly clay soils. I just have one quick query. Normally, to improve the bearing capacity of foundations on the clay soil, there are two options. One is to increase the depth of the foundation, and the second is to increase the width of the foundation. So here, alternatively, you are suggesting to put the sand bed and then geocells. Yeah, it is improving as well. But what, did anyone make any cost benefit study? Just
No, we don't. We didn't do any cost benefit study. Yes, definitely, those options can be thought of. Like, of course, increasing the width and the depth of the foundation, that's basically one will do. And of course, if you are having medium stiff soils, providing the reinforcement, it may be much more beneficial. Increasing the size and all, it also involves different things, no? Concrete, more cement usage and other things and all. But in general, if you compare the financial things, obviously, geosynthetics provide a sustainable solution in terms of reducing the carbon footprint and other things. I am sure if we do some analysis, definitely 30 to 40% of difference would be arised if you get the financial things. But we don't have any data. Yes.
Okay, thank you, Professor.
Yeah.
Thank you. One more question we can take, I think.
Any specific case studies where it has been implemented on the ground?
No, we did not get anything. This is only just research thing.
Due to the time limitation, I think we have to move on to the presentations of the.
Thank you all.
Presentations. So, on behalf of the organizing committee, I thank our theme speaker, Dr. Murali Krishna, for his excellent presentation. And sorry that we could not take more deliberations because of the time limitation. Now we will move on to the presentations. I think I will hand over the forum to Dr. Arish for conducting this section. There are seven presentations here. I think we can go with the 6 minutes itself, and then after that we have the discussions.
I would thank you, madam. Let us stick to 5 minutes for each presentation, followed by a couple of minutes for a questionnaire, because we need to wind up the session before 5:40 in the evening.
5:40. Yeah. We have 50 minutes in our hand.
Yes, madam.
50 minutes in our hand, and 7 presentations are there.
So around 5 minutes, followed by 2 minutes of questionnaire, madam.
Okay.
Okay, madam. May I call
So
upon
Veena,
the-
Siddhi here, basically I can see Professor Jay Mohan. So he has 2 papers that includes 2 more. Professor Jay Mohan, are you presenting or anybody from your side?
Dr. Jay Mohan, can you
Yeah,
can you
he's on mute actually.
Unmute
your
yourself.
mic?
Hello,
Unmute
madam.
yeah. Are you presenting or
Yeah,
somebody
yeah,
else
yeah,
is
yeah,
presenting?
yes.
Okay. Then,
Madam, I have my 2 papers that 215 and 217.
215 and 217. Oh,
Yeah, yeah.
okay. Then
So,
we have 9 papers.
yeah, we have 9 papers. So
9 papers, so we
better
have
we quickly
definitely
go
put,
ahead.
5
Yeah.
minutes. We'll put it as 5 minutes. Okay.
so
Yeah,
we
Harry,
will have
floor is yours. Go ahead.
yeah, we'll have 4-minute presentation followed by a 1-minute questionnaire, sir. That's all we can do. And let us stick to the time, madam. Let us not extend time under any circumstances. Let us stick to the time.
So you please keep the watch.
I'll do it. I'll do it. I'll do it.
Okay.
I'll do it.
Okay.
Thank you. May I call upon the first,
Yeah.
thank you. And may I call upon the first presenter, please? You can share your screen. It's
Can you read out the paper and just read out the
variability
title?
in settlements of foundations. Variability in settlements of foundations on fine grained soils. It's by Deepthi, Nageshwar Rao, and Professor Madhav. Is there anybody present? Yeah, Deepthi. So this is 2006. Deepthi, you have 5 minutes, 4 minutes for presentation, followed by 1 minute for questionnaire. Your time starts now. Go ahead. Deepthi, you have your presentation.
My name is Deepthi. My research topic is variability in settlements of foundations on fine-grained soils under supervision of Dr. C.H. Nageshwar Rao and Professor M.R. Madhav. During design of foundation, settlement is an important criteria to be taken care of. It is a vertical downward movement of the structure due to the consolidation of the soil because of the increased load. There is always a little relationship between variability of the ground and the scope of the investigation. If we consider SPT n value as a base for a design of foundations, and if there is change in that conditions, then that becomes a challenging aspect. So my research is towards to find the variability in settlements of soil, considering two traditional methods, one in order to understand the advantages and limitations of the methods. Elastic settlement depends upon the foundation type of the soil, and foundation shape. And elastic settlement is derived based upon the theory of elasticity and time-dependent elastic settlement. Literature study, Bowles in 1987 studied estimation considering influence depth up to depth of 5B. Braid in 2007 developed normalized load settlement curve in order to overcome assumptions in bearing capacity equation. It et al. In 2009 designed charts considering for square raft foundation using both physical and numerical modeling. Hassan in 2017 modified Schmittman's method using integration for fast and reliable results. Methodology. To find the settlement using Schmittman et al. Method, and to find the settlement using Berlin and Burbridge method, and to find the variability in settlements of soil considering three size of footing, that is 2, 4 and 10 meters for a pressure of 100 kPa, and to define the suitable method for given soil profile. I have considered the geotechnical investigation report at Dankani Kharagpur section, which comprises of 23 chainages. This is a Borlaug. This is the variation of SPT-N at various chainages. We can see here the variation is constant up to certain depth and then increasing with depth. And for some other chainages, it is increasing and decreasing with depth. Schmittman method is developed using strain measurements of some literatures and theoretical solution of Alvin and Euleri and the FEM analysis in order to obtain the strain distribution triangle method. The formula to find the settlement is C1 C2 Q sigma IZ by ES into ZI. Coming to Berlin and Burbridge method is developed based upon the regression analysis of around 200 case histories. First, to find the settlement, depth of influence need to be determined. That depends upon whether the variation of SPTN increasing or decreasing with depth. If it is increasing, we can use case 1, that is Z dash is equals to 1.4 B by BR power 0.75 into BR. If it is decreasing with depth, then Z dash is equals to 2B or Z double dash. Here Z double dash is the soft layer depth. Whichever is smaller, we can use that condition. The formula to find a settlement is alpha 1, alpha 2, alpha 3, shape factor, width factor, and a pressure factor multiplied with reference width. These are Schmidt-Mann results. Based upon the deformation modulus, it is divided into different layers. These are thickness of each layer and the SPTN of particular layer. After convert to QC, the relation I have used is 2n. Since the soil pressure is silty clay, further convert to deformation modulus, I have used the relation 2.5 QC. This is strain influence factor at center of each layer, and this is the ratio of influence factor to deformation modulus multiplied with the thickness. And the summation of all the layers multiplied with depth correction factor, creep correction factor gives the final settlement. This is for 2 meters footing width. Similarly, for 4 and 10 meters footing widths, these are the settlements. Coming to Berlin and Burbridge method, if the soil profile is not uniform, that is, if variation is of increasing and decreasing with the depth, it is difficult for us to finalize which case to be considered. So what I have done is...
Can you rush to your conclusions, please? We are running short on time.
So this is the graph obtained by considering various ratio obtained at various strainages. We can see a ratio is greater than 1 at some of the strainages and shows a peak value that is greater than 3. Because at these strainages, SPT-N value is greater than 15, which implies that higher values of N gives higher values of settlements in Schmidt-Mann method. But in Berlin method, the higher values of N is being averaged and predicts less value of settlements. Ratio shows a less value, that is less than 1. At these profiles, SPT-N value is very less, around 3 to 1, which implies smaller values of N does not being affected in Schmidt-Mann method, and the Berlin method is being reflected and gives more settlements. This is the angle of deviations obtained in order to find which case is more suitable. This is the angle of deviation for 2 meters footing width. For increasing and decreasing with depth, the angle of deviation is almost similar. But for 4 and 10 meters footing width, the angle of deviation is different. From this, we can tell that in general, Schmidt-Mann settlements are higher than Berlin and Burbridge settlements. For footing width less than 4 meters, Berlin method is more suitable if the soil profile is not uniform. And for footing width greater than 2 meters, Schmidt-Mann method is more suitable. The ratio shows as a variation of 3 for steep strata at shallow depths. The ratio shows a less than 1 for soft strata whose SPT-N value is less than 3. Thank you, sir.
Owing to the paucity of time, we will not be taking any questions. So we'll be proceeding to the next presenter. At the end of the session, if we have time, we will come back to the questionnaire, please.
Yes,
may I call upon the next presenter? May I call upon the next presenter?
Yes, sir.
Yeah, Deepti, you can leave. Okay. Yeah. May I know your name?
I am Abhijit Anand from IIT ISM Dhanbad.
Yeah. Abhijit, you have 5 minutes, 4 minutes
Yes.
for making your presentation, followed by 1 minute of questionnaire. Please.
Okay, sure, sir. Thank you everyone. Good evening, everyone, and thank you IGC for giving me the opportunity to present my work. This is my topic: probabilistic investigation on seismic bearing capacity of shallow foundation on unsaturated fly ash deposit. Due to the shortage of time, I won't be going to the details about the introduction. But as we already know, based on a very critical literature review, that fly ash can be utilized in geotechnical engineering applications successfully. And when fly ash is used as a structural fill in geotechnical engineering applications, and the most critical parameter which we have to investigate is its bearing capacity. Now, then the question arises, then what is the novelty of the present work? The novelty of the present study is that in the literature so far, very less or no consideration of unsaturated behavior has been considered of the fly ash deposit. The bearing capacity has only been dealt under static condition, and no seismic condition has been considered. A very less consideration has been considered. The non-linearity of matrix section with depth has not been thoroughly investigated, and the bearing capacity analysis has been considered only under deterministic framework. Therefore, the present study tries to addresses all these problems which have been discussed. Now, the quantification of shear strength under unsaturated framework. I won't be getting into the details due to the time limits, but Liu et al. 2010, he tried to quantify the shear strength in terms of he tried to incorporate this non-linear variation of shear strength with respect to matrix section, and he proposed a modified molecular failure envelope, which is given in equation 3, and this term, it is known as the apparent cohesion, and this particular term basically incorporates or basically quantifies the non-linearity of shear strength in the analysis. Going further, when a steady state infiltration is taking place in the vertical direction, like infiltration or evaporation, then the matrix suction variation with depth does not remain constant. Okay, so what have been done in the present study, the variation of this matrix suction with a depth has been incorporated by assuming a steady state infiltration rate ratio, which can be quantified as Q by Ks, where Ks is saturated hydraulic conductivity and Q is the magnitude of surface flux. Basically, once we are considering this steady state surface flux condition, then our apparent cohesion does not remain constant. It becomes a function of the depth and the effective saturation. This saturation is a function of since effective unit weight is a function of degree of saturation. So it also does not remain constant. It becomes a function of jet. So we have developed, in the equation 5 and 6, you can see that the apparent cohesion is not constant. It is a function of the infiltration rate ratio and the depth, and similarly for effective unit weight as well. So this is the geometry of the problem which has been considered in the present study. The groundwater table has been assumed, and above the groundwater table, a variably saturated fly ash under the steady state infiltration rate ratio has been considered. These are the parameters which have been adopted from pertinent literatures, and for the analysis, finite element method tool study has been adopted, a well sensitivity study has been carried out, and a standard fixity boundary condition has been incorporated. To validate the numerical model, the results were compared in terms of Tajani's bearing capacity factor and gamma with several solutions available in the literature. And as you can see, a very good agreement between the result obtained in the present study and the developed solution has been obtained. Now coming back into the deterministic bearing capacity analysis, the systemic bearing capacity has been defined in terms of a dimensionless ratio. It is basically bearing capacity to gamma V, and analysis have been carried out considering 5 different infiltration rate ratio and 5 different horizontal seismic acceleration coefficient values.
Abhijit,
And
last minute.
Yes, sir. I'm wrapping up, sir. So these are the results which I got with variation in KH and QY KF. As you can see, with increase in the QS value, the system bearing capacity ratio is decreasing along with KH value. Now, coming to the probabilistic analysis, since determination of geotechnical parameter is not involves a lot of uncertainty. Therefore, to incorporate those uncertainty in the present study, this factorial design approach has been adopted, and these are the distribution of the various parameters which have been considered. And based on these, on the uncertainty of the parameter, these are the ANOVA result. Now, the point which is noteworthy here is that the factor infiltration rate ratio has a 40% percentage contribution, and seismic acceleration coefficient value has 23% contribution on the overall seismic bearing capacity ratio. These are the plots which depicts the variation of seismic bearing capacity ratio with all the 4 different random parameters which have been considered in the present study. And this is the prediction model which have been developed based on the uncertainty in the 4 parameters. Now, what is the utility of this prediction model? It considers the nonlinearity of matrix suction. It is a much more accurate representation of SVCR, seismic bearing capacity ratio, and the unsaturated fitting parameters like alpha and n has also been incorporated in the analysis. Now, to conclude, the first and the major highlight of the present study is that the matrix suction substantially affects the seismic bearing capacity ratio under one-dimensionally statistic surface flux boundary condition. This has been the major outcome of this particular presented study. Under deterministic analysis, the reduction of SBCR with KH, and which is a very obvious result, the system bearing capacity was obtained with to be reducing with increasing KH value. However, among all the random input parameters, Q by KS was found to be the having the highest contribution in the seismic bearing capacity ratio. Also, the water retention characteristic parameter alpha and n had comparatively lesser contribution on the overall seismic bearing capacity ratio. And finally, to conclude the session, my presentation, it has been found out that the Q by KS has a substantial effect on the bearing capacity and has to be considered. It has to be considered while designing a shallow foundation. These are the differences. Thank you.
Thank you, Abhijit. May I call upon the next presenter, please? You can stop presenting.
Yes,
may I call next presenter, please?
Could you say the name? Who should be presenting?
Actually, sir, that order 9, bearing capacity of reinforced CNS soil bed on clay soil with inclined reinforcement considering kinematics. Mr. Rajsekhar Reddy here?
No, I think that paper is not here.
Okay, then may I call upon Arya Das or Ashish Kumar, study of pull-out behavior of bell-shaped anchor without and with tie in clay medium. It's not there? Because I saw it, man. 212 is there. Arya Das was there here.
Yeah, Arya Das was there previously.
But okay, so we'll scoot because we'll go without and may I call upon.
Yeah, she is present. Arya Das is present.
Yeah. Arya Das? Sir, Jaimon sir, can you mute yourself, please? Can. Because it will take the bandwidth, basically. Yeah. Mr. Arya Das?
She is trying to present.
Arya Das, you need to go and make present now. Option is there. There you need to click the application, the PPT. Then it will show. I think you are doing the screen. Arya Das, are you there? No.
Yeah, it is coming.
Yes. Yeah. Arya Das, you have 5 minutes to make the presentation. You are not audible. Arya Das, you are not audible. You have 5 minutes to make the presentation. Kindly stick to the time, please. Mr. Arya Das, are you able to hear my voice? Would you please unmute yourself? Unmute. There is a mute mic button. Just press it. It will unmute itself. Mr. Arya Das, you can unmute yourself. There is a mute button is there and you can. Okay. Madam, shall we proceed to the next one? Bina ma'am?
I think we can proceed to the next one and we will give the chance after the next one.
Because this being online, we are bound to have these hiccups. Yeah.
Okay, you can proceed to the next, that is 14.
Yeah, 14. Is Tanya Deb or Sujit Kumar Pal anyone here? Tanya Deb
Yes,
is
sir.
here?
Yes, sir. I'm Tanya Dev. I'm here.
Yeah, Tanya, you just make your presentation.
Yes, sir. Yes, sir. Right now I'm sharing.
Yeah. You share your presentation. And the time now is 5:06. You have 5 minutes to make your presentation. Kindly stick to the time, please.
Yes, yes, definitely.
Okay. Anya,
Yes, sir.
Yeah, make a presentation, make your PPT, open it and
Yes,
share
sir.
it.
Yes, sir. I'm sharing. I'm trying to share,
There,
but
there
not.
is a present now option. Click it.
Yes,
That option, you click the slide, then it will open. It will come out for everyone.
present now. Here I your enter
When you
screen.
click it, there is a window or an entire screen.
Yeah, yeah. A
When
Windows
you click
screen.
the window,
Yes,
you
yes, yes,
choose the
yes, yes,
PPT
yes.
one. Full screen, make it full screen. Yeah, better. Go
Sir,
ahead.
now it is visible.
It is visible. Go ahead, please.
Okay, okay, okay. I'm Dr. Tonaya Dev, and now I am presenting my paper. Its ID is TH0214, and it's entitled "Mobilized Fictional Share and Deadweight of Sandwich Contributing to the Pullout Resistance of Belt Ankle Pile in Sand." So, as abstract, I can say this study explains the pull-out resistance of belt ankle pile under vertical tension based on few aspects. These are variation in embedment ratio, variation in thickness ratio, bell angles, and nonlinear failure surface in dyed and non-dyed sand deposit. The pull-out resistance is analyzed as a combination of frictional shear and dead weight of sand. The range of value of analytical values of pull-out resistance are found out. The parametric studies are conducted based on the ratio of mobilized frictional shear to pull-out resistance and ratio of dead weight of sand to pull-out resistance. Bell anchor pile basically is an enlarged base anchor specified by its diameter, base dia, shaft dia, bell angle, embedment ratio, diameter ratio, and anchor may be deep and shallow. In a shallow anchor, the failure surface reaches up to the sand surface, and here the study is focused on the shallow anchor only. Earlier, the pull-out resistance was predicted by measures theory and artificial theory of Morse. Then linear concept of linear failure surface. Mathematical model of linear failure surface has was introduced, and the
Excuse me, Tanya, I think you can straight away go to your work
okay,
and
okay.
otherwise won't
So
get time.
here, okay, so madam, here this is the objective. This is the presentation of 1G 2D belt anchor panel under vertical pool in dyed and non-dyed dry sand deposit. And a 2G belt anchor panel possessing a bell angle base alpha, base diameter dB, and shaft diameter ds is embedded in dyed and non-dyed dry sand deposits. Under vertical pool, as applied stresses are acting along the vertical plane of the plane, a couple of symmetric non-linear failure surfaces are formed in both the sides of each panel. These failure surfaces are generated from the anchor base and terminated in the sand surface. For the mathematical realization purpose, these slip surfaces can be interpreted as three-dimensional axisymmetric failure sand surface in same scale. Here, the intention is to found out the value of predicted pull-out capacity. This study attempts to investigate the predicted values of pull-out resistance, ratio of mobilized frictional shear to pull-out resistance, and ratio of dead weight of sandwich to pull-out resistance of belt anchors on account of variation in embedment ratios, diameter ratios, and well angles. This is the diagram of a grain size distribution curve of sand sample. This is classified as SP. This uniformly graded sand is in this present study is procured from local market. Um, the preparation of foundation media with dry sands make it easy to maintain the density of sand within the testing tank. This is the presentation of a schematic view of experimental setup. Um, Here we can see the model of the panel. A 1 mm thick mild steel plate is used to fabricate 2D panel. the length and height of each panel is 590 plus minus 5 m and 650 mm respectively. The thickness ws of shaft part of the panel is 26 mm. The bell part are having the range of thickness 92, 80, 68 and 56 mm. So these are the
Time is
from
running
the
out. Can you Tanya, time is running out. Would you just go to your conclusions and make it brief, please? It's 5 minutes.
so
Okay.
this is the presentation of failure surface in both the sides of the panel, and this is the total mathematical process. This is the from here I can draw the conclusion. With the increase of embedment ratio, pull out resistance is gradually increased.
Tanya? We lost connection. Tanya? Can you hear us? Can you hear us? Hello, Tanya? Arif?
Yes,
Dr. Arif?
ma'am. Yeah. Let us go to the next presenter, please,
Yeah,
ma'am.
yeah. We will
Yeah. I think she made her presentation. Yeah.
yeah.
We have 15. No.
Yeah, 15 is there.
Yes.
Demon, sir. Yeah,
Yes,
sir.
yes.
You can make your presentation, sir. Now the time is 5:14. You can take 5 minutes, sir. 5:19. You can wind up the presentation, please.
Yeah, okay, sir. Thank you.
Thank you, sir.
So I have two papers. First is 215. So good evening, all of you. I am Professor Jay Mohan from Trivandrum. So this is the work done by my PG student, that is Mr. Idu PS40, and the topic of presentation is influence of moment on load settlement behavior of circular footing resting on clay soil. So this is the brief overview of my presentation. Now come to the introduction. You see some of the foundations. See, because usually we are aware of foundations, we are see which are resisting vertical loads. But in certain structures, rather than vertical loads, moments will be the deciding criteria. Compared to vertical loads, moments will be much more, as in the case of foundations for transmission towers or foundations for the retaining walls, etc. So in this research, so we are trying to find out the influence of moment on the load settlement behavior of a foundation. So here, but usually wherever in the foundation where moments are the deciding criteria, the type of foundation provided may be either a short pier foundation or maybe a pile foundation. So these type of foundations are quite costly. So we are trying to find out the influence of moment on the load settlement behavior of a shallow foundation, and also on various geometric parameters. So these are the objectives, that is influence of moment on the load settlement behavior, and influence of depth of foundation on the rotation of footing, and influence of vertical load on the foundation on on the rotation of footing. And also suppose if you provide a reinforced foundation bed, how much improvement we can achieve. So these are our research objectives. So these are the materials used. We use clay soil. And we analyze our circular footing. And for reinforced foundation bed, we use sand. And as reinforced, we use flow grid. And these are the properties of materials used. So this is a circular footing, and this is the loading arm. This is a test tank. As you can see here, diameter of the circular model footing was 100 millimeter, and thickness was 20 mm. Material was mild steel. So for the reinforced foundation bed, we use sand, this manufactured sand, and we use circular geogrid sheets having diameter of 3 times the diameter of foundation. These are the properties of sand used in the reinforced foundation bed. These are the properties of geogrid used in the reinforcement. This is the setup. So this is a schematic such, this is a schematic diagram. So through one jack, we applied the vertical load on the foundation. Through an eccentric jack, we applied the vertical load, which created an additional load plus moment. So this is the model circular footing, and the settlements on both sides were measured using dial gauges of 0.01 millimeter sensitivity. So this is the photograph of the setup, as you can see here. So the moment is applied, and one load was applied concentrically, and there was an eccentric load with an eccentricity of about 245 millimeter, and the eccentric load is P2, concentric load is P1, and the diameter footing is 100 millimeter. These are the various parameters. We varied the vertical load on the foundation. The concentric load we varied. We also increased the moment. We varied the depth of foundation. We varied the thickness of foundation bed. So these are the parameters varied. So this is the schematic sketch. This is the reinforced foundation bed. This is the foundation. This is the concentric load. This is the eccentric load. This is the eccentricity. And B is the diameter of foundation. So this is the foundation soil. And D is the depth of foundation from ground level. T is the thickness of foundation bed. And so this is a photograph of the tilted foundation. And then we did finite element analysis using Plaxis 2D. This is a geometric model. This is the deformed model. You can see. I'm going a bit fast. So now for modeling soil, we use molecular model. Since it is a circular footing, we use an axis symmetric model to model the system. And and for discretization, we used 15 order triangular elements. There was the interface element to find out the contour pressure distribution between soil, with footing and soil. And of course, now coming to results. Now this is the influence of depth of footing. Now this is the plot of tilt versus moment, and this green line. So this is for a see this black line. So this is for a surface footing, and this green line for d by 1, and this red line for d by 0.5. As you can see, as the depth of foundation increases, the tilt reduces slightly. One thing. Then, so this was carried out with a constant vertical load of P1 as 130 Newton, and for various moments and the depth of footing. Then now this is influence of vertical load on foundation on the tilt and moment. So this is a plot of moment versus tilt. Now you see this green line. Green line is when the vertical load was 0. When the concentric load was 0, there was only eccentric load. The tilt was minimum. As we increase the vertical load, the tilt also increases because the torque load increases up to 130 Newton. But for 170 Newton, for further higher vertical load.
Sir, Jaymohan, sir, yeah, time is running out, sir. Okay. You have another more presentation to make. Yeah,
of course. Then I
please.
This is the effect of moment. As the moment increases, the load settlement behavior, actually as the moment increases, the settlement increases. This is the effect of depth of foundation. As the depth increase also, the settlement reduces. This is the effect of reinforcement. So this is without reinforcement, and these are with reinforcement without, these are with foundation but without reinforcement. These are with reinforcement. Blue is for one single layer and brown for double layer. But with additional layer, there was no much improvement. But with the thickness of foundation bed, there was a bit improvement. These are the conclusions. So the depth of embedment reduces tilt and settlement. Moment that is such that influences the load settlement. And the vertical load, with the increase in vertical load up to a particular limit, the tilt increases. But with after a particular value vertical load, the tilt reduces. That's what we found. Thank you. So shall I move to my next presentation?
Yes, sir. Go ahead with your next presentation, sir. Please, sir. Please.
Okay. Thank you. Share my screen. Yes, sir. So now this is the work done by my student Amrita Varsha. So this is on the horizontal load deformation behavior of shallow circular footing. Because see, yes, sir, in our designs, in mostly we consider only vertical loads. But suppose, see, there are certain structures such as like retaining walls where the horizontal load is also much considerable. So for such foundations, so this overview of my presentation. For foundations where horizontal load is a deciding criteria, so we wanted to know what. So we want to investigate about the horizontal load versus horizontal deformation behavior. So that is the main objective here. Again, there are some parameters influence of depth of foundation and influence of vertical load on the horizontal deformation and tilt. And of course, we try to minimize horizontal deformation by providing micropiles. So these are the materials used. We use clay soil, and modern footing was circular. These are the properties of soil. These are micropiles. These are steel rods having diameter 3 millimeter and length 150 mm. This is the same circular footing, and we did the methodology was same. We did laboratory scale load test and finite element method analysis using Plaxis 2D. This is the schematic diagram. So we applied vertical load using a jack, and we had a reaction on the side. We applied horizontal load also using a jack. So the both vertical deformation, horizontal deformation, both were measured. There was a datum bar, the datum horizontal and vertical. We had both. And so this is the figure. So this is setup. This is arrangement for applying vertical load. This is arrangement for applying lateral load. And of course, these are the parameters. Vertical. So these are the vertical loads applied. These are the depth of footing. We tried. We varied the depth of footing also d by b, where d is the depth of footing, b is the diameter of footing. So 3 values of depth of footing. This is a schematic diagram. Here we apply the vertical load. Here we apply the horizontal load. See, sir, there was a jack here. So there's a jack. There's a proving ring. I hope you can see the rod. This rod was connected to the foundation. At the top of foundation, you can see the same rod here. It was through this rod. So just above the foundation, the horizontal load was applied. You can see the lateral deformation of footing. You can see here. There was tilt as well as lateral deformation. Yeah, these are the micropiles. Now again, of course, we do so we did finite element analysis using Plaxis 2D. These are the typical curves. This is the typical stress distribution. Now, coming to the results. Now, when the vertical load was 0, there was the lateral deformation was minimum when the vertical load was less. As we increase the vertical load, lateral deformation reduces, because as we increase the vertical load, the normal stress increases, base friction increases, so the lateral resistance also increases. This influence of depth of foundation. As we increase the depth of foundation, also the confining depth increases and lateral deformation reduced. Now here, this is the effect of lateral load and depth of foundation on the rotation. You can see the rotation increases only up to a particular value of lateral load. After a particular lateral load, we have the lateral deformation. After a particular value lateral load, the rotation ceases, except for d by b 0.5. That's one observation we made. And once you place micropiles, this curve is for without micropiles. By the addition of micropiles, we can reduce the lateral deformation up to a large extent. Similarly, rotation also. By adding micropiles, we can reduce rotation also to a large extent.
Sir, Jaymohan sir.
Yes,
Yeah, please.
Thank you, sir.
Thank you, sir. Thank you. Sir, if you have any questions, we can accommodate a quick one question or two here. If not, we can move to the next presentation.
Yes, I have a question. How you validated your Plaxis analysis?
I'll show you. I think I have
how your experiments results are correlated with the Plaxis analysis.
Yeah, madam, please see the slide. So here, madam, these dotted lines are of Plaxis and the solid lines are for experiments. Madam, can you see this?
Okay.
Yes, sir.
Thank you, sir.
Yeah,
thank you, sir. May I call upon? Yeah, thank you, sir. May I call upon the next presenter, Mr. Professor Ravi Sundaram Garu? Are you there, sir?
Yes, I'm there. I will present my presentation.
Thank you, sir.
Yeah, meanwhile, paper number 9 is also available now. Mr. Rajshekar Reddy has kept something in the chat box. I think we need to accommodate the paper also.
Yeah.
We can take it. Yeah.
But first, let Professor Ravi Sundaram Garu.
After the queue, we'll take it.
Yeah. I'll do it, sir.
Ravi sir, please share the screen.
Yes, I'm just sharing. Are you able to see?
Yes, sir. Yes, sir.
Yeah,
Make it full screen, sir. Yeah, make it full screen, sir.
Are we now seeing on full screen?
Yes, sir. Thank you, sir.
Thank you for giving me the opportunity to present this presentation. It's slightly different from the kind of presentations which have been made earlier. I will be talking about a unique high-rise statue. This is the statue of Lord Shiva at Nath Dwara. This image you see here is an architect's visualization of how the statue was to be made. It's a 107-meter high statue constructed on a 500-meter high hillock in Nathdwara. It is the tallest statue of Lord Shiva in the world and the fourth tallest statue in the world. Here you see the Lord in sitting posture with a trishul by its side. Um, the statue covers a base area of 65 meter by 45 meters. So this is where Nathdwara is. If you can see how to go from Jaipur towards Nathdwara. So this is the statue as constructed. You can see the architecture and the aesthetics, the posture, the expressions of the Lord, the radiating a peaceful countenance, the sculpture's detailing make the statue unique and imparts a divine look. There's an irregular configuration in both vertical and horizontal planes as per the IS code. So that is why it is a irregular statue. So the conceptual planning here, the structural engineering and design of the mainframe supporting the external shell was made, and then the site geology, geotechnical characteristics of the rock and slope stability assessment has been done. Experienced and resourceful construction agency capable of translating the exquisite ideas into reality is most important. A well-defined construction methodology for foundations, main gravity load and lateral load resisting frame, external shell, the skin and the organ shapes, all have been planned very meticulously. All these contributed to making the statue look gracious, elegant, and divine. The statue is planned for a design life of 250 years. So let us see what the implementation steps were. First, a mock-up of the statue was made. Then geological and geotechnical investigations were done. A hill slope stability was assessed. And then the foundation design and of course the rock anchors have been provided. The posture and expressions and visualizations and body proportions has been done by an expert sculptor. In situ casting of concrete using full-scale molds, including 3D modeling, has been done, and jointless 20,000 square meter of concrete skin has been poured and integrated into the structural steel frame, and then wind tunnel testing was done. This presentation is limited to the geotechnical aspects of the project. So, going to the geology and geophology, rock deposits in the area belong to the Nathdwara group. Formations belong to the Middle Proterozoic age. Comprises quartzites, phyllites, calcareous phyllites, and bands of dolomite and calcitic marble. The topography is hilly and undulating. The general trend of the hill is north-south with inclined steep dips. It's in a semi-arid area. The area is traversed by numerous nalas, and there's hardly any flow in these nalas except during monsoons. The site area is approximately 10,000 square meters. And the hillock height is about 500 meters off the national highway. 20-meter level variation between the bottom and the top. So gentle slope as such, 8 to 11 degrees. So that's the layout plan, and this is the geotechnical investigation done, and using a hydraulic rotary rig, using a double tube core barrel. So the stratigraphy here, you can see the 4 boxes here. Quartzite encountered from the ground surface to 15-meter depth. Rock is moderately weak to moderately strong and slightly weathered. A rock at shallow depth to 1.5 to 4 meter depth is weak, fractured, highly fractured, and has iron stains. Below this, the fracture frequency reduces, and it is strong to and slightly weathered. These are some of the borehole data. You can see the recoveries and RTD values on the left side of the bore log. A slope stability assessment was done. As per the visual assessment, the hill slopes are fairly stable. Rock is exposed at the ground surface. The slopes within the plot and surrounding areas are not too steep, 8 to 11 degrees. Slope failure in the slip failure mode or block failure mode is unlikely. And below 3 to 4 meter depth, the rock mass has widely spaced joints. So this is a view of the construction in progress of the foundations. RCC raft with raised pedestals to support the statue. It was cast at 4 meter depth. The bearing capacity analysis was done for the rock, and the raft was designed for a bearing pressure of 700 kilonewton per meter square. Rock anchors were designed to support the statue for long-term stability against wind and earthquake loading. So these are the parameters which have been used for the design of the rock anchors. It's an earthquake zone 4. So 8 meter long anchors embedded 7 meter into the rock and 1 meter into the raft foundation has been provided. The anchors were installed in 100 mm diameter drilled holes with FE 500 32 mm TMT bars grouted into the rock. And the anchors were designed to resist the entire lateral force due to wind and earthquake, ignoring the friction resistance between rock and concrete.
Sir, the time is running also. Please, sir.
Yes, sir, I'm finishing in a minute or so. Anchors were placed all along the periphery of the concrete forming wall at the base of the statue. So that is the layout of the anchors. The slope protection measures, proper drainage, shoulder drains, and where a rock has been excavated, adequate precautions were taken, and concrete paving extending 1.5 meter beyond the exterior foundation was provided, and of course the rock anchor. So this is the structure and construction. So there is an internal space has a lift and for maintenance and monitoring purpose. Some internal floors are for public use and museum. The steel members are designed to provide the flexibility, and the external skin has been specially poured using fiberglass bolts. So that's the statue and its surroundings. You can see the Lord majestically and benevolently ruling over the area. I thank you very much for the opportunity. You see here a drone picture of the statue. Various people who have been involved. My pleasure thanking them, acknowledging. Thank you very much.
Thank you, sir. Thank you for your nice presentation. And owing to the paucity of the time, we are moving ahead with the next presentation. May I call upon Mr. Rajshekhar Reddy? Rajshekhar Reddy?
Yes, sir. Yes, sir.
Yeah, are you there, Rajshekhar?
Yes, sir. I'm here, sir.
Yeah. Can you just make your presentation? The time now is 5:35. You have 5 minutes to wind up. Please stick to the time, please.
Grant permission.
Thank you.
So, sir, still some problem is that can't share your screen. You must grant some grant permission in order to screen share. Still screen sharing problem.
No, it is not like that. All people, none of the.
Must grant permission in order to screen share.
You just go to the present now option. It's not showing up for you.
Yes, you go to presentation.
Yeah, go to the present now option and make
screen and window. Both are there, sir.
Yeah, window. Choose a window or show that the PPT option. It will show up.
But still, can't share your screen. You must grant permissions in order to screen share. Sorry, sir.
Unfortunately, we are not the hosts for this meeting. We are not the host for this meeting. Unfortunately.
Dismiss. How to?
It's not showing up. It's not showing up for you.
Yes, sir. Not showing.
I think you can just come out of the meet and then once again you enter it and try. By that time, we can move on to the next person.
Okay. Okay. Okay.
Yeah.
Hello.
Hello.
Hello. Rajshekar sir, are you there?
Yeah. Arya,
We can go for the next presentation. I think Arya Das was there previously. Is she there?
Madam, she has finished her presentation, madam. It was only the last because the time allotted to her was finished, right? So if we bring in, we will be losing the time on others. We are having 3 minutes.
No,
on the
Arya Das has not presented. Kenya
Yes.
only presented. Kenya only presented. Arya Das could not open it as Raj Reddy.
Okay, madam. We'll allow Tanya Das to make this.
No, Tanya Das already.
Yeah,
Tanya
Arya Das. I'm sorry, Arya Das. Yes. Yeah, Arya, you have 5 minutes to make your presentation. Please stick to the time, please. Okay.
Good afternoon.
Yes. Please go ahead.
That slide is visible. Yeah. Your mic is muted, I think.
No, mic is there, madam. Voice is there. I think he has joined from 2 different. Mr. Arya Das, your voice is not audible. Mr. Arya Das.
Arya, can you hear us?
She's using chat box. Basically, she is able to hear us. I think
Yeah.
there is a problem with her mic or so.
Okay.
Ariadas, can you please take it and come back in few minutes? We'll go to the next one because we are running short of time. Please.
Yeah, that's true. So we'll.
Yeah, thank you. Yeah, probably we can move to the next presenter.
Yeah. Bipasha Das is there.
Yes, 26.
Hello, ma'am.
Yes, Bipasha, you can make your presentation. Just
Okay, ma'am.
close your PPT.
Okay, Bipasha.
Ma'am, can you see my slide?
No, not yet.
No.
Okay.
There is a present now option. Yes, it is now visible.
Okay. Okay. So can I go ahead?
Yeah, you have 5 minutes, Bipasha. Stick to the time, please.
Okay, I'll try. Okay. A very good evening to all the listeners present. I, Bipasha Das, will present on experimental studies on load settlement behavior of cohesionless soil using bamboo grid. The advent of industrialization has led to implementation of various modern structures, but due to lack of good quality of soil, it has become a need for ground improvement. These are the few need for ground improvement: to reduce settlement, utilization of all types of soil, improve soil texture, mitigation of liquefaction, etc. These are the few techniques available for the ground improvement.
I think, Bipasha, you can go to your objectives and your actual work.
Okay, okay. These are the few literature reviews, and then okay. Can you hear me now?
Yes, you can.
Yes, yes. The test setup is present in Jorhat Engineering College, where I completed my MTech. Materials used are sand, steel plate, bamboo, which is procured from RFRI Jorhat. These are the few lab data from few datas from lab. IS 1 888 1982 is used thoroughly during the project.
when bearing capacity was calculated experimentally, it is obtained that bearing capacity increases with relative density. But when calculated theoretically, maximum bearing capacity is obtained in Meyerhof, followed by Plexis, and the least in Heysen, irrespective of angle of friction and relative density. Plexis 2D is a finite element method which is used with 15 noded axisymmetrical model. The following properties are inputted during analysis. The bearing capacity is obtained from load displacement curve. For reinforcing, bamboo is used, which is easily available in northeastern region. These are the following benefits of bamboo, but being a natural source, it needs treatment. CCB is the best method. Square apertured and hexagonal apertured bamboo grid are placed in required depth and bearing capacity are obtained. The improvement factor decreases with increase in difference of depth between footing and bamboo layer. Similarly, the analysis was conducted in plexis with bamboo features. If these are the following results. Effect of number of layers of bamboo grid with plexis 2D is also analyzed. Aperture plays an important role. Bearing resistance offered by TBG, that is hexagonal aperture, is more than square aperture. Settlement with three layers of hexagonal is more than 4 layers of square aperture. Bearing capacity is also more with 3 layers of hexagonal. These are the few conclusions and a future scope which can be done in later stages. And these are the references few used and during this experiment or during my project. So thank you.
Thank you, Bipasha.
Okay.
We are running short on time. We will take the questions later. So, do we have the next presenter, Mr. Debashish Manna? Debashish Manna, are you there? Sorry?
Yeah, I'm Santosh Kumar. I'm going to present on behalf of Debashish.
Okay, Santosh Kumar, please go ahead. You have 5 minutes to make your presentation. Please stick to the time. Okay?
Yes.
Thank you.
Am I visible? Slides are visible?
Yeah. Go ahead, please.
Okay. Yeah, I'm starting now. Good evening, everyone. Myself Santosh Kumar from IIT Kanpur. Here, I'm going to present the paper titled Ultimate Bearing Capacity of Strip Footings on Resting on Reinforced Embankments. Straight away, move on to the objective due to shortage of time. So here, the objective of the paper has been set to estimate the bearing capacity of the footing resting on an embankment, with the embankment is reinforced with a single layer of reinforcement. So here, the analysis, this class of problem is solved here using the upper bound limit analysis. These are the major assumptions which has been used in the analysis. So the fundamental principle in the limit analysis is, first we need to assume a feasible failure mechanism and followed by the imposition of limit theorems. So the solutions can be finally obtained using any optimization techniques. For example, if you have a bearing capacity problem, the footing, now you can see that we are assuming a double-sided multi-block failure mechanism. So when the footing is loaded, each block will move with a velocity. So this upper bound principle states that we can obtain a true upper bound solution by equating the dissipation of energy in the soil with the external work done. So in the coming to the current problem, so since taking the advantage of symmetry, we are just showing the half failure domain. Here you can see the footing. Each and every block below the footing can be defined by a geometric variable, set of geometric variables, kinematic variables like velocities. So these kinematic variables can be obtained by drawing this velocity diagram, velocity autograph. So in order to impose this upper bound limit theorem on this particular problem, this particular failure mechanism has to be geometrically compatible and kinematically admissible. So for that, it has to satisfy these constraints. So by satisfying these constraints, the algorithm has written in MATLAB and the optimization has been carried out using fmincon solver. So now the bearing capacity can be expressed as given in equation 1. So due to shortage of time, I'm not explaining all these things. So now the results are presented in terms of two factors: increment factor, which tells us the effect of the reinforcement in the embankment, and influence factor, which can tell us the influence of the sloping ground in the analysis. So coming to the results, here you can see this result. This figure shows the optimum depth of reinforcement. That is the depth at which the reinforcement can give a maximum enhancement factor, maximum bearing capacity, which is shown here, which depends on different soil properties as well. So the effect of this increment factor with various input parameters has been shown in table 1. Here you can see with the increase in the friction angle, you can see a considerable increase in the enhancement factor. On the other hand, because of the sloping ground surface, you can see there is a reduction in the enhancement factor. Thus, we can say that the soil properties, the mechanical properties have a positive effect on the bearing capacity, whereas the sloping ground has the negative effect on the bearing capacity. Now, this figure shows the collapse mechanism obtained in this method. Here you can see with the increase in the friction angle, we can see there is the extent of failure zone is also increasing. So the authenticity of the present study is actually is tested with the available comparative study. Here you can see when the present study we are using considering a sloping embankment. If we keep beta equals to 0, the same code has to work for the horizontal ground as well. So keeping that in mind, we just made the validation study. Here you can see the present study matches very much closely with the available upper bound solutions like Sobra in table 3 and McCloskey in table 4. These are upper bound solutions. The present results almost matches exactly with almost closely with these results. And coming to the conclusions, here the ultimate bearing capacity is calculated using the upper bound limit analysis, and the effect of slope and the reinforcement is expressed in terms of two different factors. So here what we observed is like unlike the influence of phi and influence of friction angle and the sloping angle is more when compared to the quotient and the setback distance. The present results are found to match reasonably well with the results reported in the literature. Thank you. Due to shortage of time, I have to rush up.
Thank you, Santosh.
Yes, sir.
Yeah, we'll move ahead with the next presenter. Rajshekar Reddy, are you there?
Yes, sir. Yes, sir. I'm here, sir.
Yeah, can you make your presentation now?
Yes, sir.
Please. Hello. You share your screen. You're sharing not your screen. Yeah, now it's visible. Make it full screen, please. Make it full screen. Yeah, go ahead. You have 5 minutes, Mr. Rajshekar. Try to wind up at the earliest.
So the topic is capacity of reinforced CNS soil bed on clay with inclined reinforcement and considering kinematic stress. I am a research scholar from JNU Hyderabad, being under the guidance of Dr. G.V. Narasimha Reddy and Dr. E. Sai Reddy. And content contains introduction, objective literature, methodology of study, results and discussions, and conclusions and references. And generally, reinforced soil structures are widely used throughout the world for different purposes. Especially for reinforced soil wash, source, bearing capacity improvement, source, etc. And these are used to resist the disturbing forces by transferring them back to the soil through interface bond resistance between soil and reinforcement and tensile forces between the reinforcement elements. So, due to the scarcity of ground for construction of structures due to globalization and industrialization, we are compelled to use for ground with low bearing capacity and more swelling in nature. The industry's practice is to replace with the granular fill up to the width of the foundation or increase the dimension or a combination of both with geocentric reinforcement. And my objective of study is develop a method for estimating the bearing capacity of non-linear response of soil bed reinforced with inclined reinforcement over in situ clay layer, considering kinematics. And a parametric study to quantify the effect of various parameters on the bearing capacity of CNS soil bed with inclined reinforcement over in lines of clay. And literature review, majorly we have used two Mayhawks and Madhav's papers here, extended. And the Mayhawk's punching shear failure model for thin, dense sand bed on clay is extended to include the axial tension in inclined reinforcement. And for additional bond resistance mobilized due to transverse deformation of inclined reinforcement, theory proposed by Uma Shankar and Madhav is used. And methodology here, a stick footing of width B resting on thin sand bed overlying clay. And here we have used CNS soil to make it a profile. And the cohesion of the CNS soil is neglected, and phi is considered, and reinforcement is placed at a depth of U from bottom of the footing. And here punching shear failure of the footing is considered due to the self-weight of the structure. Footing, the soil column beneath the footing moves along with the footing, and due to that, reinforcement will also goes down. Due to the movement of reinforcement, upon normal forces would be acting on the bottom surface of the reinforcement, and with the movement of the soil column, shear stresses would be developed on either side of the soil column. Generally, reinforced structures allow more deformation before failure. With the more deformations, then it will behave as a non-linear. That's why we have considered here as a non-linear soil reinforcement response. And due to the here the overburden stress consists of two QT and QN resolved to the inclination of reinforcement, and due to the shear stress is developed on both sides of the soil column. And here, due to the inclination of reinforcement, this axial pull-out resistance is offered by the QT, directly offered by the QT, and QN is normal stress and QN tan phi r. So total mobilized pull-out resistance is the combination of QN tan phi r and QT LEI. And due to the upward normal stress, the tension is mobilized in the reinforcement. And here we have used normalized bearing capacity to apply the over wide area. So here T star N is the normalized tension developed in the reinforcement, and T star N is the normalized transfer force obtained from Madhav and Dhamma Center. So parametric studies done for H by B of 0.5 and 530, pi by pi of 0.75, and WL of deformation at rates of the footing of reinforcement is 0.01, and variation of alpha from 0 to 20 degrees, gamma B by C from 0.9 to 3.6, and LR by B from 2.5 to 3.5, and beta separate fill factor from 0 to 3000, and stiffness factor of mu of 500 to 1000. Here, this is y-axis is normalized bearing capacity considering non-linear response of soil and reinforcement. Here you can see due to the inclination of reinforcement, the bearing capacity, normalized bearing capacity increased by 42%. 42% due to the inclination of reinforcement, additional normal stress would be acting on the reinforcement. Due to that, additional frictional resistance will be developed, and due to the transverse deformation of reinforcement, additional bond resistance would be developed due to transverse deformation. And from here, so there is an increment of 42% here due to the increase of reinforcement, and due to the inclination of mu from 500 to 10,000, there is an inclination of 19% in the increase in the bearing capacity due to the stiffness of soil. Due to stiffness of soil, Additional normal force is required due to this bearing capacity would be increased. Here, in the year also, due to the increase of rainfall, reason is same. And whereas due to the gamma wave increase in gamma V by C from 0.9 to 3.6, due to this increase in bearing capacity increase by 58% for 10 degrees of increase of reinforcement. This is due to the density of sandbed and vital footing or overlying ledge cohesive layer, clay layer. Here, due to the normal stiffness factor beta, this bearing capacity is increasing due to increase of reinforcement about
Mr.
43%.
Bhaskar Reddy, Mr. Bhaskar Reddy, please, the time is running out. Could you just wind up the presentation?
I'm telling, sir. Sir, it is validated with Rajalakshmi's analysis, and our this thing is the results of present study corresponding properties is 1.69. This is more than this one. The conclusions are so by considering the kinematics, the lesser shearing resistance soils can be used, and there is a significant increase in bond resistance is observed between reinforcement and soil. This improvement is more pronounced to the consideration of inclined reinforcement and kinematics.
Thank you, Mr. Rajshekar Reddy. And we have a couple of minutes. I'm going to allow for a quick questionnaire. All audience can ask the speakers who have made the presentation, who are here, they can ask them these questions. We have a couple of quick minutes before we wind up this session. Unfortunately, we really don't know which of the speakers are present who have made the presentation. So keeping that in mind, with all the limitations, the session is now open.
Arif, we don't
Yes,
have
sir.
Arya presented, right? I think he or she is still missing. I mean, Arya has a presentation? Arya Dutt? Arya Dutt, are you there?
Yeah, she's there. She's there.
Yeah, are you going to present, Arya? We are unable to hear you. Sorry, really sorry for that.
I think some problem with their audio.
Right. Probably we request administrators to take your presentation to the next program, I mean, theme 2 tomorrow sometime. Is that fine? Yeah, you can present in the next coming session on theme 2, maybe tomorrow or day after tomorrow. Yeah, I'll indicate to the administrators. Okay.
Okay, that's fine.
Yeah, thank you. Yeah. Arif, yeah, Professor Bina, floor is yours. You can say.
Yeah, Arif.
Yeah, madam, you can conclude the session, madam. I have taken down the titles. I have graded them. I will send my grading to Professor Sirish.
Okay.
Okay, madam. You can conclude the session.
Arif, we'll talk about that later. It was only Arif will meet a little later. Once session is closed, I want to talk to you both. Okay? Please don't log off.
Okay.
Okay. So we have a very good presentation and very good session with 10 presentations. Of course, one could not present it because of some technical problem. Then anyway, we started with the Deepti. She presented the variability in settlements of foundations in fine-grained soils. Then modeling of unsaturated soil in Plaxis 2D was presented by Abhijit, and then Tanya Dev tried to present on mobilized frictional shear. Then Dr. Jayamohan presented 2 papers regarding the foundation, circular foundations models, and the effect of horizontal loads as well as the moment on circular loads. And we heard from Ravi Sundaram the geotechnics of a unique irregular high-rise statue, and we got a presentation from Vipasha regarding the bamboo geogrid, and Mr. Santosh Kumar had presented the bearing capacity of strip footings on reinforced embankment using upper bound limit. Due to the paucity of the time, we could not give deliberate time for deliberate discussions on it, and we we have to cut down the presentation time also. Sorry for that, but we have to go for the annual general body meeting is there, as you know. So we cannot extend the sessions further. So on behalf of organizers, I thank all the presentators and for giving excellent presentations within a very short time. Also thank Arif, Dr. Arif, for excellently controlling the time and keep the.
Thank you, madam.
Moving. So thank you, Dr. Sirish, also for conducting the session. Thank you, Anna.
Yeah. Professor Beena, I'll take the floor, and yeah, thank you so much for organizing this event spotlessly, and especially Professor Arif, who managed time, who went back to the went after each presenter, and I mean with a comfortable zone. But yeah, he managed the time very well. And definitely we had a very good deliberations and presentations today. And with this outset, I would like to thank both of you and all the presenters who made their presentations. And one particular case, I will take it to the organizers for tomorrow. Arya Das will be presenting your presentation tomorrow, probably. And I'll talk to them, and probably organizers will contact you on that. Okay. And thank you very much for being here with us today. And we'll conclude the session officially. Thank you very much. And I request chair and co-chair to present for a few minutes, and yeah, the rest can actually leave the hall. Thank you so much. And we'd like to also thank Place on Record, very well presentation given by Professor Murali Krishna. So yeah, we are missing all the ceremony part of it. So virtually a big thank you. Yeah.
Thank you all. Thank you, Professor Sirish and Professor Arif. And
thank you, Murali. Thank you, sir. Thank you, Beena ma'am, for handling the session. It was really an honor to co-chair this session with you, madam. Thanks a lot.
Thank you.
Thank you. I request the participants to leave the meeting, please. Ms. Geetika, Ravitejapi, okay, please. Sundar Pandian, Surendra Chiliboina. Yeah. If the administrator is there, he can take the initiative, please.
Yeah, Miss Nagalakshmi, I think she is administrator. She can actually sign off the other presenters.
Yeah.
I'm unable to do it.
We can't do, sir. We can't do.
Yeah,
we don't
yeah.
have the attributes.
Sure.
Ramana Garu, you can leave, sir. Ramana Garu. Yeah.
There is Mr. Surendra. Yeah.
And Dr. G.B. Ramana is there.
Yeah.
Yeah.
Surendra is there. Miss Lakshmi, can you please sign off Surendra, please? There are 3 dots. Actually, you can click on it, and you can actually remove them from the participation.
Is he one among the administrators, sir? I don't know.
I'm not sure. I know Miss Lakshmi. I got the number, so I was contacting her.
No.
Miss Lakshmi. Arif, I think he's also administrator. No problem. Yeah.
Okay.
So actually, Professor Beena, I was asked to mark some of these presentations. They are really good.
Yeah. Yeah.
Okay. So it was a little confidential until last day. It seems I'm not
Yeah.
really sure how many will be selected and they
Yeah,
will be marked. So I
yeah.
could not discuss because moment we started, everyone joined. So I could not tell you in person. I don't have your mobile number.
Yeah.
And I messaged Tarif, and probably I have marked all the
Yeah,
presentations.
I also prepared a list because I
Okay. Oh,
got
excellent.
yeah
Excellent.
I got a mail from organizers
Correct. Correct.
on what are the bases on which
Correct.
yeah. Then
Yeah, I forgot to announce that in the beginning. I mean, I cannot announce it openly, so so I didn't do that. Yeah.
Anyway, quality of
Both of
answers.
you actually, ma'am, both of you can discuss and give me numbers.
Yeah,
I also have given my scores here.
Yeah.
Probably, but yours will be valid because as a chair and co-chair. If there is a conflict, then I'll put my numbers up. Yeah, is that fine?
We cannot put a mark on the quality of answers to the question because we didn't ask answer questions to everybody. So
And there is another, madam, the two presentations by Professor Jay Mohan and by Professor Ravi Sundaram, they can't be evaluated because they were made by the faculty, not by the students.
Yeah.
Correct.
The award is for the students?
Only for students, I guess.
Only
Probably
for the students.
Springer will give some kind of check or something like for buying books or something like that.
Okay.
I was told. I'm not really sure what is going to happen at the end, last day.
Okay.
So, but if the
So we can remove those things anyway.
Yeah.
That's okay. Then in my mind, what I feel is Santosh Kumar. He has put some material which is valuable, I think. Some theoretical analysis and.
Yeah, 228, madam. The team 228, you mean?
228.
Yeah, and even the
26 also was a good presentation, even though its time is very short. 26 also I marked on those. I mean, those are my ranking. What I feel. Then Abhijit was also.
yeah, it was. Yeah.